Section 1.5 is on solving inequalities. An inequality is a mathematical statement in which the two quantities are not necessarily equal to each other. So here's a little box from your textbook that shows about inequalities. Slide this down a little bit here. Okay, in this case, we're going to be using greater than and less than. So if we say that x is greater than 4, its graph looks like this. That means all numbers that are greater than but not equal to 4, so we use an open circle over 4. If x is greater than or equal to 4, then we have the same sort of line and we have a closed dot or a solid circle right there over the 4. If x is less than 4, again the open circle, and this time going in the negative direction, and x is less than or equal to 4, a solid filled in dot over the 4 and going in the negative direction. Notice that the open circle means that 4 is not a part of the solution, while a closed dot means that it is. Let's take a look at an example here. Write an inequality for the following statement. The product of 7 and a number is no more than 7. So the product of 7 and a number is going to be 7x, and it's no more than 50. Did I say 7? I meant 50. Is no more than 50. Now, no more than sounds like greater than because I think of greater and more meaning the same thing. But think about what it means then. It can be no more than. It can be that value, but it can't be bigger. It can be smaller. So that's going to be a less than or equal to 50. So 7x is less than or equal to 50. The solution of an inequality is the set of all numbers that make that inequality true. It's not going to be just one number, it's going to be a whole set of numbers. And the following properties can be used to solve an inequality. Actually pretty similar to the ones that we saw for solving equations. Let's see, so we have the transitive property. If A is greater than B and B is greater than C, then A is greater than C. The addition property says that I can add the same number to both sides of the inequality and it remains true. Subtraction says I can subtract the same number from both sides of an inequality and it remains true. With multiplication, I can multiply both sides of an inequality by a number. If that number is positive, the inequality symbol stays as it was before. However, if the number I'm multiplying by is negative, so for example C is less than 0, then notice the inequality symbol flips. Same thing for division. I can divide by the same number on both sides. If the number I'm dividing by is positive, the inequality symbol remains the same. If the number I'm dividing by is negative, then you have to flip that inequality symbol. And I think I said that here. Notice that multiplying or dividing by a negative number reverses the direction of the inequality symbol. So let's take a look at a couple examples here. So we need to solve the inequality 4 times the quantity x minus 7 is greater than negative 20. And let's graph the solution. So first thing I want to do is distribute that 4. Okay, and now I'm going to solve. To do that I need to add 28 to both sides. So 4x is greater than 8. Notice, even though I have a negative 28 there and a negative 20 there, I'm not doing multiplying, so there's no flipping. Divide by 4 and x is greater than 2. Don't flip because I divided by a positive number. Now to graph that solution, I'm going to draw a number line. I'm going to put a 2 in the middle. I'll put one number larger and one number smaller. Since this is a greater than, not a greater than or equal to, I'm going to have an open circle and I'm going off in the positive direction. That means that any number that is greater than 2, so 2.00001, will work. Second example here. Plumber A charges $75 for a service charge and $40 per hour. Plumber B charges $50 per hour, but no service charge. How many hours must a plumbing job last for plumber A to cost less than plumber B? Well, I'm going to write expressions that show me what their charges are. So plumber A, it costs $75 for him to walk in the door and $40 for every hour that he's there. And I just broke one of my rules. I didn't define my variable. Let H equal the number of hours that the plumber spends there. Okay, so the cost of a plumbing job for plumber A is going to be 75 plus 40H, 40 times the number of hours. For plumber B, he has no flat service charge. He just charges $50 per hour. So what I need to know is how long must a plumbing job last for A to be less than B? So the cost of a plumbing job with plumber A, 75 plus 40H, I need that to be less than plumber B. And solving that, subtracting 40H from both sides, and then dividing each side by 10, I get that 7.5 is less than H, or H is greater than. Notice I just flipped the whole thing, keep the inequality opening to the H and pointing at the 7.5. So a plumbing job must last more than 7.5 hours for plumber A to cost less than plumber B. Just as with an equation, sometimes an inequality can have no solution, or the solution can be all real numbers. Here's some examples. Is each inequality always, sometimes, or never true? So for number 1 here, let's go ahead and distribute. So I'll get 3x plus 9 is greater than or equal to 6 plus 3x. And if I were to subtract 3x from both sides, I'd end up with 9 is greater than or equal to 6. Is that true? Yes, it is. That's always going to be true, because 9 is always going to be greater than or equal to 6. It's technically not going to be equal to, but we do have the word or in there, so that's going to be always true. Let's take a look at example 2 here. I'm going to go ahead and define like terms. I'm sorry, not define, combine like terms. So negative x plus 4, is that less than negative x plus 4? Well, a number is not less than itself. If that were less than or equal to, yes, that could be true, but this is never going to be true because something is never less than itself. Two inequalities that are joined, by the word and or the word or are called compound inequalities. To solve a compound inequality with the word and in it, we need to find all of the values of the variable that make both inequalities true. To solve a compound inequality with the word or in it, we need to find all of the values of the variable that make at least one of the inequalities true. So here we have a couple examples. My first one says 5 minus 2m is greater than or equal to 21, or 2m minus 1 is greater than or equal to 21. So I'm just going to negative 21. I'm just going to solve each of these separately. So subtracting 5 from both sides, I get negative 2m is greater than or equal to 16. And then dividing by 2, I get m is less than or equal to negative 8. Don't forget to flip that inequality sign because I divided by a negative 2. Let's do this one. So I get 4m, adding 1 to both sides, is greater than or equal to negative 20. And dividing both sides by 4, m is greater than or equal to negative 5. I don't flip there because I did not divide by a negative number. I divided by a positive number. For your final answer, don't forget to put the word or in there. So this is my answer, and now I need to graph that. So I'll draw a number line, put those two values on there. So m is less than or equal to negative 8, looks like this, and m is greater than or equal to negative 5, looks like that. And then my last example here says 3 is less than 5x minus 2, which is less than 7. This is actually an and inequality, and there's two parts to it. So 3 is less than 5x minus 2, and 5x minus 2 is less than 7. I like writing them this way because I think I can do it in fewer steps. My goal is to get this center part between the two inequality symbols down to just an x. To do that, I want to add 2 to all these parts. So I will end up with 5x is less, I'm sorry, not 5x, 5 is less than 5x, which is less than 9. And now divide each part by 5. I'll get 1 is less than x, which is less than 9/5. And that is actually an and inequality. It's basically is saying x is greater than 1 and x is less than 9/5. Let's go ahead and graph that. Put those two numbers on a number line. 9/5 is a little bit less than 2, but I'm just going to put 9/5 there. And since this is not an or equal to, I'm going to have open circles. And I like writing it this way because notice that x is between those two numbers. So I'm going to draw a line between those two circles because that line represents the values of x that make this inequality true. So in this section, we took a look at solving inequalities, went over some of the properties on how to do that, and took a look at a word problem that uses an inequality.